say, the second video. All right, let me see if my pen's working, which a lot of times it stops. But anyway, if you read over problem number 6, the most important thing you could have noticed is that you're asking for the probability, why not use my highlighter, huh? The probability that the mean lifetime of a phone is less than something. This is a probability about the mean. That is, we're asking for the probability that X bar is less than 23.8 months. When you're working with the mean, and again, you have to work with the assumption that you can work with the normal table, meaning normally distributed or the sample size is large enough. But the fact that I'm working with the probability associated with the mean tells me the mean associated with the mean is the mean given in the problem, 24.3. But the standard deviation of the mean is the standard deviation given in the problem, which is 2.6. But I have to divide by the square root of the sample size, which is 33. When you do your math here, that standard deviation comes out to be about 45.26. So again, key here is the probability associated with the mean. Your first thing is to get the mean. It's the mean of the population. But again, it's the standard deviation that's different. You're given the population standard deviation. You have to divide by the square root of n. Now I have this information. I just simply get to the table. So I'm going to convert this to standard normal by subtracting the mean and dividing by the standard deviation. When I do my calculations, that number comes out to be a negative 1.1. This is the scenario working with the table because I'm to the left of the number, right? Smaller than the number. So when I look up my number in the table, I get 1357. So about a 14% chance that for this problem here, the sample has a mean which is going to be less than 23.8. Got it? There's my answer. Now, for the last two problems, I really didn't work these in class with you, and these are going to be extra credit on your test, okay? So, what do I mean by this? Well, the table you've been working in one direction, meaning you were given a number, you wanted to find the associated probabilities. Now, you're going to be given a probability and you want to find the associated number. So, let me see about calling up my normal table here. So, let's do that right quick. I'm going to call up my normal table. And there is my normal table. All right, let me get back to the problem now. I want to find the z-score, the actual number where if you look on the chart, here's z, 98.87% of the area under this talk too much sometimes, huh? 98.87% of the area under the distribution curve lies to the left of z. So what we're saying is that below z is 98.87% of the data. Well, that's the way the table works. But again, I don't know what z is. I have the probability, 0.9887. So I'll go to my table, find my table, and I'm going to look up 98.87 somewhere in this chart, right? Notice the numbers are increasing, all right? 98.87. Hopefully I find it. 98.87. There it is right here. There it is, okay? That's associated with the number 2.2 with a hundredths position of 8, correct? So 2.28. Moving on to B. Again, I'm trying to find a number Z. But for this one, 82.12% of the data is above Z because it's to the right of it. Well, the table gives me numbers below Z. So if 82.18% is above it, that tells me 17.88 is below Z. So I need to look up the number 0.1788 in the table. Can do better than that, huh? It's hard to write with these pens. You gotta get used to them. So 1788 is below Z. So I go to my table again. Look for 1788. That's going to be down here somewhere, hopefully. There it is, 1788. So here's the number associated with it. Minus 0.9, and the hundredths position is 2. So negative 0.92 is the answer. And there you go. Okay? All right. So anyway, so I'm going to scan through it so you can see the answers. Okay? This one was a yes. This one was a no. I'm going to show you this at the end, but I'm not going to walk you through it. All right? Here's 3A, B, C, 4A, B, C, D, 5A, 5B, 6, 7, and the last one, right? Oh, that's not the answer. That's, you know what that is. All right, so I'm going to show you the answer to number 2. Okay? Okay, here's the answer to number 2. I'll just note that when you want the expected value, which is the mean, you're simply multiplying outcomes to the associated probabilities. You're multiplying these numbers together. Then you're adding all of these up, and when you add them up, there's your expected value. This variance is a little bit more complicated. Your first step is you have to subtract from the mean from each one of these numbers here. That's what I'm doing, subtracting it and then squaring it. Once you do that, then you multiply by the associated probabilities down here. So for example, this number here was obtained by taking 6 minus the mean, squaring it, then multiplying it by 0.25. And that's what's happening with each one of these, and then they're added up. And when I add them up, I get the variance, and the standard deviation is the square root of the variance. Good luck. Wish you the best.